Hello, welcome. Let's try to solve another Leetcode problem 3242, design neighbor sum service. So for this problem, we are giving a grid, so all the numbers are going to be from 0 to n squared minus 1. Yeah, so there will be n squared minus 1 elements, and all the elements will be distinct elements at inside of the range. So this means for each of the value, if we are going to find the value, we must know the position. Yeah. So let's check what we're gonna return. So basically we're gonna use two methods. One is adjacent sum. So for example, let's just use the first example. So the first example is like we are giving a grid. It is 0, 1, 2, 3, 4, 5. All the numbers are unique, and it is inside the range from 0 to n squared minus 1. So 6, 7, and 8. So for example, if we are going to calculate adjacent sum, and this value is going to be 1, so it's going to be the four directions, top, bottom, left, and right, so it's going to be 6. Now let's just use another example, maybe the diagonal sum. So for this 8, so for this 8 diagonal sum, it is this 4, and there's no other numbers, so it is only this 4, so that is why the result is 4. Now we're going to design an algorithm to solve such kind of a problem. Yeah. So we can directly use the brute force because the grid length is only 10. Now let's do some preparations for this problem. Yeah. So we're gonna use the grid. So we're gonna use self.grid gonna equal to the grid, because we will never change this grid, so we don't need to copy the grid. Yeah. And let's prepare self.r and self.c gonna be length of the grid and the length of grid 0. Now let's just prepare a dictionary, because for each of the value we need to know the position. So let me define a dictionary. It's going to be default dict, and inside it's going to be a left. Now we're going to check the position of the value. So for r in range, self.r, and for c in range, self.c. Yeah, we want to check the positions, so we're going to directly use the dictionary. So self.d with this value. So the value gonna be grid r and c, and the position gonna be array, which gonna be r and c. Yeah. So we need also to prepare some directions and diagonals, because there are 4 directions and 4 diagonals. Let's just prepare that. Self dot directions, it's gonna be 0, 1, 1, 0, minus 1, 0, and 0, minus 1. So this is going to be the 4 directions. Yeah, let's just also prepare the 4 diagonals. So the diagonals, let's just use the self.diag, diag. So inside it's going to be 1, 1, 1 minus 1, minus 1 minus 1, and another direction which is going to be a minus 1 and 1. Yeah. Now let's just check the first method, which is going to be adjacent sum. Yeah. So first of all, let's find the position. So rc is going to be self.d with this value. Now we're going to check 4 directions. So for dr, dc inside self.directions. We're going to update the row and column, which is going to be r plus dr and c plus dc. Now we're going to check it. So if a row is inside the range, it's going to be self.r, and column is also inside the range, which is going to be self.c. We're going to update the final result. So it's going to be the grid, row, and column. Finally, we're gonna return the final result. So the result gonna be starting from 0. Yeah. And similarly, we can copy the code to calculate the diagonal sum. Yeah. So for the diagonal sum, we need to change from here, which is gonna be the diagonal, and I think everything gonna be the same. We only need to change this one, and we check the diagonal, and we get the final result. Now let me just run it to have a check if it works. Here should be self.grid and self.grid. Yeah, now as you can see, it works. Now let me submit it to prove that it can pass. Yeah, as you can see, it passed for all testing cases, and it's pretty fast. And for the time complexity, if we are going to calculate the init, that is n square, and if we call each method adjacent sum, so that's gonna be on time. Yeah, and this will also be on time. Yeah, so the final time complexity gonna be on, and also depending on how many calls of the adjacent sum. Yeah. Let's check how many calls if it is sad. So it's gonna be 2 times n squared calls, and for each call it's gonna be on time. So the final time complexity gonna be n cubic. So n cubic is just 1000. That is why it's so fast. I think for this problem, that is just checking your basic programming skills. I mean, if you can use any kind of language to make a basic programming, because everything is really easy to understand and really easy to do. You just need to have the basic programming skills to solve this problem. Thank you for watching. See you next time.